Hello everyone, welcome back to my channel AKB Tutorials. In this channel we are discussing various topics related to mechanical engineering, and today we will continue, that is engineering graphics. So in last video also we have seen engineering graphics, and in this video also we will see some topics related to engineering graphics. I am Ashok from AKB Tutorials. So let us start today's session. Now in last class we have understood the basics of engineering graphics. So we were discussing about the title block. So the title block is positioned at the bottom right hand corner of the drawing sheet. So if we see the title block, it looks like a rectangular box where all the information related to the particular drawing is supplied on this. So the measurements, so I have discussed, and here there are 3 columns. So this is the title block. So the various information contained in the title block, that is the information related to that particular drawing which is drawn on that particular sheet. So the title block is drawn at the right hand bottom corner of the sheet, and this box contains the information of scale. All the objects are not possible to draw on the given standard sheet of paper. So the object size may be very large or may be very small, or sometimes the small objects can be drawn as per its own size. So that scale information, so here the scale will be written and thereafter semicolon and say 1:1 or 5:1 or 1:10. So this information will be written. So by using which scale is the drawing is made. So drawing is made, so if it is a very large object, then we have to use the reduced scale. So this is the reduced scale, say 1:10 or 1:2 or 1:2.5 or 1:1000. So like this information will be here, and if the object is very small, so if we draw the projections of that object, so it is not possible to read the drawing. So thereby the object to be drawn in a very large scale. So say 5:1, 10:1 or 100:1, like this information will be written here. And the first one, that is scale 1:1. So if the object size is smaller and the actual size of the object can be drawn on the sheet of paper, then it is 1:1 scale is used, that is called the full scale. So this one is known as full scale. This one is called the enlarged scale. And this is called the reduced scale. So what is scale? Scale is the ratio of drawing size to object size, or it is given in terms of RF, that is representation fraction, is equal to drawing size to actual size of the object, actual size of the object. So always it is not possible to draw as per the size so on a sheet of paper. So that means, so large size object is represented on this sheet with the help of a reduced scale, and smaller size object, very small size objects like needle, like the parts of wristwatch. So these parts are very small, so that can be drawn by using a large scale. And here a building, a bridge, or a town plan, so etc. are drawn by using reduced scale. And full scale objects, say anything, say we want to draw the view of a pen. So this pen can be drawn very easily on a sheet of paper because the size and drawing sheet, it can be represented easily on a sheet of paper or in a standard size drawing sheet. So now next information, so here we will write like this: scale dot means semicolon, then 1:1 or 1:5 or 10:1 or 100:1. This information will be here in this box. Now next we will see next box. So it contains the angle of projection. That is, this box contains the angle of projection. Angle of projection. So in this box, so whether the first angle projection or third angle projection is used for drawing the object. So that information will contain here. So by seeing this box or angle of projection, we can ensure that drawing is done by using first angle projection or by using third angle projection. So now, what is actually angle of projection? So now, if the object is placed in the first quadrant and the drawing is made, then that angle of projection is called the first angle projection. If object is kept in third quadrant and the projection of the objects are made or images of the objects are made, then that is called third angle projection. So the symbols, we will see the symbols. So here the symbols of angle of projection will be given. So let it is a three-dimensional view, and this plane is called the vertical plane, and this plane is known as horizontal plane, and a truncated cone, say a truncated cone, it is lying on horizontal plane. A truncated cone is lying on horizontal plane. If we see the front view from this side, the observer is here. So if the observer looks this object, so the front view will be projected on VP. So this will be like this. So this side diameter is equal to this side diameter, this side diameter is equal to this side diameter, and as it is a symmetrical object, so there will be center line. Now if we look from this side, so left hand view will be projected on PP. So on PP, if you draw PP here, so this is the PP, that is called profile plane. On this plane, the right hand side view will be projected. So from right hand side, if we see, we can see this area, means this circle as well as this bottom circle, as the bottom circle is a larger circle, means this side circle is larger circle. So we can see the smaller circle as well as the larger circle. Okay, as it is a circle, so we have to put the center line from both the side. Okay, so this symbol, so that means we have to place here this symbol of angle of projection. So angle of projection, it will be like this. Say this is your center line and this is the center line. So first smaller circle, it will be in palm, and then the larger circle. So if we draw separately, so it will be seen like this. So this is according to the first angle projection. So in third angle projection I will discuss. So the information of angle of projection will be available in this box, and here in this space the name of the organization, So here name of the organization will be written. So the drawing is made for, say, Tata Power or Tata Logistics or other company, and for school colleges the name of the college or school or the university will be written here. Say Haldia Institute of Technology, so here Haldia Institute of Technology will be written. So the drawing is made for that particular organization, and here in this space the title of the drawing will be written. Title, say drawing is for, say, flywheel, or say it is for tailstock. So that information will be written here. So title of the drawing, and here in this box or in this space it will be written the drawing number. Sometimes that particular component have more than one drawing. Say tailstock, it has several parts, so it may have 10 drawing, 15 drawing like this. So 15 number of drawing sheets. So that information will be written here, say 1/20 or 5/20, like this information will be written here in the space that is called drawing number. Now the leftover space here, the name and date, this space leave blank, name, then date. So date of drawing and name. So here first column, so first this box will be designed by. So the component, the designed by. So every product is conceived by some designer. The designer gives the specification. That specification is translated to drawing by the draftsman. Okay. So designed by the person who has designed the component, who has given the specification so that it will work well in the application. So the name of that person will be written here. Name of that person, designed by, name of that person will be written in this space, and the date of design. Now next, in this space will be written by drawn by. Who is the draftsman, who is drawing or who is translating that specification into drawing. So that information will be available here. So the name will be written here and the date of drawing. Then in this space will be checked by. So checked by means the superior of this person, drawn by, who is the senior most person of this person. He will check the drawing and compare with the design whether every information is supplied or not. If some information is left, then drawing will not be approved. So checked by. So that information, name of the person and date. Then in this the standard. So which standard is used for drawing? So that information will be available here. So in India the standard used is BIS standard, Bureau of Indian Standard, or the new name is Indian Standard. So that information will be written here, the standard. So here BIS standard. Next column, that is last one. So this space will be written as approved by. Approved by means the officer in charge of this department will check everything, whether every information is given or not, then he will sign here. So the approved by, so the person name will be here and the date will be here. So with this, all the information related to title block, I hope it is covered. And any other extra information is required to be supplied, that is to be supplied separately by the side of this. Okay, the machining information, material information, tolerance information, accuracy information, etc., or scale information. Sometimes instead of the scale, sometimes graphic scale may be used. So that information will be supplied separately. So it is, this title block is available in all the sheets, means in all the drawing sheet you have to make the title block separately. It is not that in one sheet we have drawn the title block, in other sheet we don't require, but in every sheet all the information will be supplied in the title block. Now we will see the various tools which is used for drawing of the component. So this is most important, the tools and accessories which is used for drawing the component. Tools and accessories. Tools and accessories. So the various tools and accessories used for drawing purposes. First one which is required is a drawing board. So drawing board, so we have discussed the size, various sizes of drawing boards are available, the standard sizes. So we will use here D1 drawing board. The size already discussed in the last video. So anybody who is not knowing, so you go through the last video so you can get it. Now we require a drawing sheet. So there are various standard drawing sheets, and out of which we will use for school college uses, we will use A1 drawing sheet. Okay, so we will lay out this A1 drawing sheet over D1 size board, then fix it, and we will start drawing the component. Next, what is required? The most important is T-square. T-square or mini drafter. Mini drafter. So the role of these two is same. So this is the board. So say this is D1 size board over which A1 size paper is fixed here with the help of clips. So say 4 clips are used. So before fixing the drawing sheet over the drawing board, so we have to check this upper line of the drawing sheet and the upper edge of T-square should be in one line. Then fix the sheet over the board. So if we draw the T-square, so say this is the head of T-square and this is known as the blade of T-square. So this is the blade of T square. So, and this side, so we have discussed there is a working edge. So now when we will place the T square, it will produce exactly 90 degree angle. So if we slide the T square and draw a line with the help of this upper edge, so all the lines will be parallel to each other. So that means your drawing will be very fast if you follow this, and there should be a true working edge at the left hand edge of the board. Okay, now mini rafter is fixed at some place, and so by using that you can draw the horizontal line as well as vertical lines. And for drawing the vertical lines, here say 45 degree set square or 30 degree set squares are used, 30 and 60 degree set squares are used. So for drawing the vertical lines, similar way the other lines, that is at an angle 30 degree, 45 degree, 60 degree, 75 degree, 90 degree, etc., or 120 degree or 150 degree can be drawn easily with the help of T square and set square. So for that you need a practice. Now next, the component is set squares. So there are two set squares available, that is 45 degree and 90 degree set square, and 30 degree, 60 degree and 90 degree set square. So with the help of this T square we can draw horizontal lines, and with the help of set square we can draw 90 degree angle or any other line, or perpendicular line, or any other line at a particular angle, that is 30, 45, 60, 90, 120 and 75 and 150 degree angle. Now next is drawing instrument board, drawing instrument box. So this instrument box contains so many components. Number one, the dividers, that is dividers of small size as well as large size, small size and large size. So to measure the angle, to transfer the angle, so dividers are used. Next we require we have the pencil compass, so for drawing circles, pencil compass, so it is used for drawing circles or an arc, okay, arc of a circle. Next, the next component which you require is your pencil, that is one of the most vital component. With the help of pencil we are drawing the points, lines, curves as well as symbols. So the pencil is the most important component. Here we will use the hard pencil as well as the soft pencils, so over which it is marked H or HB. So sometimes 2H, sometimes HB, okay, HB is the soft pencil as well as hard pencil. Next we require eraser, okay, and next we require French curve. French curve is used for drawing a smooth curve, okay, which is passing through 2 points or 3 points like this. Okay, next we require, that is duster, so to clean the drawing sheet as well as drawing documents before start of drawing. So these are the various tools which is used for engineering graphics to make a neat and clean drawing. Now we'll say The position of engineering drawing in a manufacturing industry. Position of engineering drawing in a manufacturing industry. The position of engineering drawing in a industry. So, as we have discussed that the idea of the product is conceived by some designer or anybody or some engineer, and he expresses the idea of the product on a sheet of paper in the form of drawing. So, the first design of the component is made. Design means what should be the shape and size of the object is made by the designer. Shape and size of the product, first it is described. Shape and size of the product. So shape and size of the product is first described, or it is called the specification of the product. Specification of the product. So the specification of product in the form of notes. So what should be the length, what should be the width, height, or the position of holes, etc., diameter of holes, everything. All the specifications are given by the designer about the product. That specification is translated by drawing department, that is engineering drawing. So, after design, the drawing of the component will be made or the product will be made, and that drawing will go to the shop floor or the industry shop floor. So, here the manufacturing of the product will be done. Okay, so the engineering drawing, it is in between the design of the product as well as the manufacturing of the product. So it is in between. So whatever the specification given by the designer, that specification is translated into the drawing in the drawing department. Then that drawing will go to the shop floor for manufacturing of the physical product, and that product will go or shipped to the customer for their fulfillment of the need or customer satisfaction. So whenever there is a need in the society or there is a problem in the society, then only the design team will work on that, and the concept of the product is developed. That concept, after that concept, the design department will decide the shape and size of the product so that it will simplify the problem, and then that specification will go to the drawing department, and drawing department will draw the product on a sheet of paper. So it may be in a multi-view drawing. So that drawing will go to the shop floor for manufacturing of the product, and then that physical product will be shipped to the customer for their satisfaction or for the fulfillment of their need. So this is the position of engineering drawing in manufacturing industry. Now we'll see the various standards which is used in drawing. Standards used in drawing. Standards used in drawing. So for engineering drawing, as per as definition of engineering drawing, the presentation of a three-dimensional object on a sheet of paper as per its shape and size by using points, lines, curves and symbols is called the engineering drawing as per its shape and size and by following the stated standards. Okay, standard means for drawing the lines or the curves we have to follow some guidelines. So these are the standards. What is the norms? Which the norms to be followed. For drawing a component, for drawing a component is called the standards. So there are types of standards. If we see, there are two types of standards. One is called the national standard and another one is the international standard. So every country has its own standard, that is called the national standard. For India, this national standard is known as BIS standard or simply the new name is IS, Indian Standard, or BIS standard, means Bureau of Indian Standard, that is the old name. This is called the standardization organization for India. It standardizes the drawing of a component, means how the lines, which kinds of lines, thickness of the lines, or drawing of curves, everything is prescribed by this organization. Next, the use of material. Next, the testing methodology, because after product is manufactured, it is to be tested. So, testing methodology. Etc. So everything is standardized by this organization is called the BIS, that is Bureau of Indian Standard. So the drawing, procedure of drawing, use of materials, testing methodology or laboratory testing equipments, etc. Everything is decided by this organization, that is called BIS standard. If any organization wants to do business inside the country, that is India, so they have to follow the BIS standard. And the standards are given by IS, then followed by 4 numerical digits, semicolon, the year of establishment of the standard. So IS 4 numerical digits, that is the particular unique digit for that particular standard and the year of establishment of the standard. Similar way, if any country wants to do business with outside of that country, then they have to follow the international standard. And this standard is known as ISO standard. The full form is International Organization for Standardization. International Organization for Standardization. So, if a country wants to do business outside their country, then they have to follow the international standard. And most of the countries of the world following this standard, that is International Organization for Standardization. And they are also prescribing the same thing, the method of drawing, use of materials, testing methodology, etc. And it is given by the standard is given by ISO, then 4 numerical digits, that is unique digit, then followed by the year of establishment of standard. Okay. So now this is all about the standards used in drawing. Okay, next we will see the projections. Projections and their types. Projections. What is actually the projection? The drawing the different views of the components or parts is called the projections. Drawing of different views of a component is called the. So in two-dimensional view, say object may be placed in first quadrant, in second quadrant, in third quadrant, and it may be in fourth quadrant. But second quadrant and fourth quadrant is not used for drawing the projections because the different views will overlap with each other. So front view and top view. So in both the cases, that is in case of second angle projection and as well as in fourth angle projection, the top view and front view will overlap each other and create confusion. That's why these two angles of projections are not used for drawing the projections. So only first angle and third angle projections are used. But in India, only first angle projections are used for drawing the objects in schools and colleges because it is decided by the standardization organization. So as per BIS, in India, if we want to draw the projections of an object, it will be done by using first angle projections. So I hope the angle of what is projections is clear. So drawing the different views of an object is called the projection. In this projection, so there are elements. So we are considering only first angle projection. First we will see the first angle projection. So we can draw by using first angle projection and by using third angle projection. So in first angle projections, the object is kept in two-dimensional view. If we see, the object is placed in first quadrant. So let's see first. Let's clear our concept by considering a three-dimensional view. So this is called the HP, VP, vertical plane, and this plane is known as horizontal plane. So similar way, so this is the horizontal plane and this one is the vertical plane. So this is also vertical plane. Now this is the first quadrant, second quadrant, third quadrant and fourth quadrant, or this is the first angle, second angle, third angle and fourth angle. And this line is called the reference line, that is XY line. Now if we look this from this direction, what you will see? We will see this plane as a line. So it is seen as a line. So this is the HP, and this plane, this vertical plane will be viewed as a line. So this is the vertical plane. So from this direction, at an angle 90 degree to this, okay, or parallel to XY line, if the beam of light is falling on this parallel to XY, then we can see this one and this one will be HP, and this is also the VP. And this point indicates this line, that is XY line. XY. So this point indicates the reference line. This point indicates the reference line, and this line indicates the planes. This is horizontal plane and this is the vertical plane. Now if the object is placed in first quadrant, so let us see here, say the object is at some distance in front of VP and at some distance above the HP. Okay. So this is the three-dimensional simple object. Okay. So this is the three-dimensional simple object. The object is placed Say this is the object. The object is placed in the first angle. Now the observer is at the right side at an infinite distance. So the observer looks the object. So parallel beam of light is falling on the object. So thereby the observer can view only this face, and the image of this face will be projected over the VP, and this is known as the front view of the object. So when the observer looks the object from right side, so the front view of the object, he can see only this face, and the view or the image of this face will be projected on VP, and that is called the front view of the object. If the observer looks the object from the top, okay, so this view or this face will be visible to the observer, and the image will be formed on horizontal plane, and this is called the top view of the object. Now after taking the images on vertical plane and horizontal plane, that is front view and top view. Similarly, if the observer looks the object from this angle, so this side view, that is left hand side view of the object, will be projected on PP. So we are not seeing PP. So front view and top view. Okay, front view and top view. So after taking the projection, this horizontal plane will be rotated by 90 degree in clockwise sense. So if we rotate this and draw the orthogonal view, so we will see this is the reference line XY, and here the front view of the object is made, and the top view will be formed on HP. So this is your HP, and this one is your top view. So in first angle projection, top view will be at the bottom of front view, and if we need a side view, the left hand side view will be formed on PP, and which will be at the right of the front view, because this PP is rotated by 90 degree in anti-clockwise sense. Okay. So this is the first angle projection and the symbol of projection. So this is the first term of cones. So if this cone is seen perpendicular to the direction, so we can find this one as the front view, which will be formed on VP, and as it is a symmetrical object, so we have to put the center line. And if we see from left, the right hand side view, the left view will be drawn at the right side of this, and we will see a smaller circle of this diameter and a large circle of this diameter. Both the circle will be visible and given by thumb lines. So this diameter will be equal to this diameter and this diameter will be equal to this diameter, though there is no space, so I have shown like this. Okay, this is all about the first angle projection. Now we will see the third angle projection. So in third angle projection, the object is kept in third quadrant. So object is placed here, say on the ground. Object is placed on ground. Third quadrant, it is on the ground. Now this is your vertical plane and this is your horizontal plane. Now if the object is looked from the right, the observer is at the right. So if observer looks the object, and here we assume that this projector, the projector is transparent. So if the observer looks the object from the right and this is a transparent projector, so that means the observer will look the object. So this will be your front view. So in two-dimensional figure I am showing. Now, if the observer looks the object from the top, this horizontal plane is also transparent. Then the observer will look this face of the object. So this will be your top view. After taking the projection, front view and top view, this horizontal plane is rotated 90 degree in clockwise sense. So when this horizontal plane is rotated by 90 degree, so this plane will assume this position. So that is your reference line XY. So if we draw the orthographic view, so this is your reference line, that is XY, and this top view will come above the front view. So this is your top view and here your front view will be formed. So this is the front view. And if we draw the so this is the front view. So this side view will be left view and left view will be positioned at the left of the front view. So left hand side view of the object will be here. So we can compare the first angle and third angle projections. We can compare the first angle and third angle projection. What we have seen? First angle projection and third angle projection. So in first angle projection, top view is located at the bottom of front view. And right hand side view is located at left side of front view, and left hand side view is located at right side of front view, at right side of front view. And in third angle projection, so this is the case of third angle projection. Top view is located above the front view, and this is the left hand side view. Left hand side view is at the left of front view, and right hand side view is at the right of front view. So this is the first difference. And second difference, here the projector is not transparent. But here the projector is transparent. Okay, next, third difference, the projection of the object is made by keeping the object is located in the first quadrant. Keeping the object in the first quadrant. Keeping the object in first quadrant. And in this, the projection of the object is made by keeping the object in third quadrant. Next, the symbol of projection. So, in first angle projection, say this is the truncated cone, and if we need to show the side view, right hand side, so this side if you want to show the view, so left hand side view, so if you look from left hand, so you can find this circle as well as this circle. So both the circle will be firm circle. So this is the smaller diameter circle and the larger diameter circle, both will be by using firm lines. If we want to show the left hand side view of this, either this or this, we can show. So this is the center line. So from this end, if we look the object, so we can see the larger circle, but smaller circle will be hidden. So the smaller circle will be drawn by hidden lines, and the larger circle will be drawn by firm lines. So either we can show these two views or we can show these two views. Now in third angle projection, say this is the truncated cone and this is the center line. Now in this, right hand side view will be placed at the right. So right of front view. So this is the front view. So right hand side, if you see, the bigger circle will be visible but smaller circle will be hidden. So for smaller circle, we will draw the smaller circle by hidden lines by taking this diameter, and the larger circle will be by thumb lines. If we want to show the left view, so then the smaller as well as larger, both the circle will be visible. So draw both the circle with the help of thumb lines. Okay, I hope with this the idea of first angle and third angle projection is clear, and the comparison between these two angle projections. So we can draw the object by using third angle, fourth angle and second angle projection also, but because of overlapping there will be a confusion. That's why this angle, second angle and fourth angle projections are not used in practice. So only first angle and third angle projection is used. In India, only first angle projection is used because of the Bureau of Indian Standard. In standardization organization specifies that the drawing to be made by using only first angle projection. And if we see in America, third angle projection method is used for drawing the projections. Okay friends, this is all about this video. We will meet soon with the next exciting video, and if the video is helpful to you, please subscribe, like and share the video. Thank you. We will meet soon.